see the science gal.
May see the science gal.
May see, may see, may see, may see, may.
Hello again, and welcome to
Ecology is the study of
Today we're
ecosystems.
going to learn about how to be a good scientist. A good
Science
scientist should be able to
rules.
properly and accurately use all scientist tools. For
T
example,
minus 5
lab
seconds.
safety. First things first, keep your
May
hair
see the science gal.
up. Keeping your hair out of your face avoids contaminating the experiment. Secondly, always remember to closed-toed shoes. Closed-toed shoes prevent the experiment to be spilled onto your feet and damage the skin. Thirdly, safety goggles. Safety goggles prevent the experiment from getting and contaminating your eyes. Fourthly, make sure to wear safety gloves when dealing with dangerous chemicals. Number 5, make sure to use heat gloves when dealing with anything hot. Those all are hot. Now, let's converse about some other safety topics. If you are to spill something during your experiment, alert the teacher right away to begin the cleanup process. If you are to spill anything onto your clothes or your skin, please report to the nearest washing station located within your lab. Lastly, always make sure to wear long pants to avoid any acid or experiment contact with your skin. Now, let's move on to our next lab scientist tools topic. Now let's move on to talking about observations. The first type of observation we're going to be talking about is called a qualitative observation. A qualitative observation includes things like color, texture, and the form of matter in which it is in, such as a liquid, solid, or gas. We often use these descriptions to describe the quality of the item we are describing. For example, we have this Jell-O here. Now, this Jell-O, as I am taking my qualitative observations, looks red, feels slippery, and appears to be in a solid form. It also looks a bit clear and is very squishy. Next, we're going to talk about quantitative observations. Quantitative has the word quantity in it, meaning we're going to be measuring the quantity of the thing that we are observing. The quantitative observations are often used using the International System of Units, or SI units. These things can include kilograms, milliliters, and millimeters. The next thing that we're going to learn today on how to be a better scientist is converting units. We can use dimensional analysis to help convert our units.
Dimensional analysis is based on the idea that you can multiply anything by 1 and not change the physical meaning of the measurement. For example, 24 inches times 1 still equals 24 inches. Now, if we were to convert it to a different unit, you would have to take 24 inches times 1 foot over 12 inches. 1 foot is equal to 12 inches. So if we multiply 24 inches by 1 foot over 12 inches, or technically 1, we can receive our answer, which will turn out to be 2 feet. The nice thing about dimensional analysis is when you set up the equation, these two things will always cancel, leaving you with this to label your final product. You know that you will be doing it right if both this unit and this unit cancel to leave you with this unit left for your final answer. Now, these are 4 good rules to keep in mind. Number 1, write down the given information.
Next up, we're going to learn about significant figures.
All right, let's talk about some of the significant figure rules. When using addition or subtraction, your answer must have the least number of decimal places as appears in the problem. Now, when you're using multiplication and or division, your answer must have. Let's talk about some rules of significant figures, or sig figs. When using addition or subtraction, your answer must have the least amount of decimal places as appears in the problem. When you're using multiplication and or division, your answer must have the least amount of significant figures as appears in the problem. Let's take a look at some examples. Our next problem uses multiplication. When using multiplication, your answer must have the least amount of significant figures as used in the equation. Writing it out, the first one has 3 and the second one only has 2, meaning that our answer must only have 2 significant figures. Using a calculator, 22.7 times 3.2 equals 72.64. But we aren't done. We must only have 2 significant figures. This being said, we must use our rounding skills. 72.6. The 0.6 would move the 2 up to a 3. So your answer would be 73. Our next problem includes subtraction. Subtraction requires that your answer has the least amount of decimal places. In this case, we have 4 on top and 2 on the bottom, making 2 our required number for our answer. When we evaluate this equation, we get 1.9378. But we aren't done. We must only have 2 decimal places behind. And we have 4. So we have to round. So we'll have 1.9. The 7 moves the 3 up to a 4. 4.
Our next thing that we're going to talk about in order to be a good scientist is scientific notation.
Now let's work on converting significant figures using the power of 10. The decimal point is always at the end of a long number such as this one, but we only need 4 significant figures. So we're going to walk it back. 1, 2, 3, 4, 5, 6, 7 times. Now we only need 4 significant digits, so that means we're only going to cut it off here because we have 1, 2, 3, 4 digits. Now we're going to round the 3 and the 2, and it looks like we don't need it since the 2 is smaller than 5. 5.783 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Now let's move on to our next one. Same deal. Our decimal is at the end of the number. 1, 2, 3, 4, 5, 6, 7, 8 this time. 3.14. 5 can round the 1 to a 2, so 2 times 10 to the 8th. Now, If the decimal starts over here, that means we're going to have a negative number as our exponent for our 10. 1, 2, 3, 4. 7.8 rounds the 0 to a 1 times 10 to the negative 4th.
Lastly, a good scientist must know how to create their own lab. Let's start with the steps that you need to know. One of the first things that you need to do is identify the purpose, problem, and the question. Write down any variables that you know that you're going to be using in your experiment, and then move on to step 2. After gathering your extra information and writing it down for your viewers to see, you should make sure to gather a new hypothesis. Your hypothesis should estimate the ending of your new experiment. After you've established your hypothesis, move on and set up your results and calculations. After you have the results and calculations, be sure to set up your procedure. Your procedure should look identical to the procedure in which you took to perform the experiment. And with that, you are now a good scientist.
May see the science gal.